Hey y'all, let's take a look at what's called logarithms. And logs are basically related to exponents and solving basically exponent problems. You'll need to get a calculator out, so go ahead and pause it and get that out. Or what you can do is use your Windows 10 calculator on your computer. You might even use your phone calculator, that's fine as well. But let's go and look at some old stuff first though. 8 to the second times 8 to the fifth, as we know, is 8 to the 7, right? Okay, 8 to the second divided by 8 to the fifth is 8 to the negative third. Okay, we subtract. And 8 squared brought to the fifth power is 8 to the 10th. Okay, just some basics about logs, or exponents. But let's look at these. I would write these down if I were you, just so you can have them in your notes to look at. Okay, a logarithm is basically an exponent. Okay, so in other words, we have something like this. 2 to the third power is 8. 2 to the third power is 8, which is true. We know that one. Okay, the base is the number to a power. It's going to be a positive number, and it will not be 1, because 1 to any power is just still 1, so we don't mess with that very much. Okay, all right, that's the 2 is the base. Okay, the anti-logarithm is the same thing as the answer. So 2 to the third power is 8. So 8 is the anti-logarithm of that little problem. All right, the logarithm of 8 to the base 2 is 3. So you're going to write this down and have this and circle it or star it or do something, put it, highlight it, put smiley faces on it, whatever, have your dog lick it, something to set it apart so you can look back at this a jillion times, because you're going to want to use this as kind of your basis for everything. The logarithm of 8 to the base 2 is 3. So, all right, how about that? Okay, all right, we're going to use this to solve a couple of problems. This is the same way we're going to write it, and write this down as well. This is the same as that. So we'll go log of 8 to the base 2 is 3. So if you can cement that in your head, a log, a little subscripted variable of 2, 8 equals 3, boom, you got it, okay? All right, let's go to the couple of problems here. This is a calculator exercise. Find the base 10 logarithm of 105. Now you'll find that you'll have log problems. Sometimes there won't be a base to this, and you'll just assume it's going to be 10. All right, if you don't see one there, it's 10. All right, so the question they're asking is 10 to the what power is equal to 105. Now let's look back again. Log little 2, 8 equals 3. So we have log little 2, 8 equals 3. Now with this, we could look at this and go, okay, this to that power is that. Okay, so base 10 logarithm of 105. Boom. 10 to the what power equals 3. Oh, excuse me, equals 105. So it might look like this. 10 to the what power equals 105. So the question is that. We don't know what this is. Now, you could probably guess. 10 to the second power is 100, right? And here's how we do it. In your calculator, let's just go to the calculator. Let's enter 105. 105. All right. And let's go next. Enter log. Okay, then you'll see log. And that tells your calculator to do this. Boom, there we go. So let's say it's 2.02. All right, and the answer, again, let's write that down. That means, that 10 to the 2.02 power, approximately, equals 105. Now, it won't be exact, but close enough, okay? So that's how you actually write this. So we'll say log, this is base 10, 105, boom, 2.02. All right, and it just keeps going. Facts about E. You should know about the term E, and that's a little e. A couple of things. It's known as a natural logarithm. All right, the abbreviation looks like this, L and N. The value is about 2.71828. It's an irrational number. Remember what irrational numbers are. They can't be expressed as a fraction. It just keeps going on and on and on with no repeating decimal. All right, interest problems, probability, calculus, all kinds of things. If you take a calculus class, you'll run across this number. This is how they calculate the approximate value. Heaven knows we're not going to do that. So they just take 1 and they add 1 over 1 plus 1 over 1 times 2 plus 1 over 1 times 2 times 3 plus 1 over 1 times 2 and just keep going. And you can tell this is going to be, the numbers you're adding are going to get smaller and smaller because the denominators are getting larger and larger. Okay, so this is about the 2.718 is about the value of E. So here's an exercise. Let's enter 105 and enter the natural log. Okay, so we have 105 and then on your calculator there is a button here. And boom, okay? So 4.65 is what we get. Now, the meaning to this, all right, is what? You remember this, the log of 8 to the base 2 is 3, right? The log of 8 to the base 2 is 3. So you write this way. Log of 8 to the base 2 is 3. So let's go. 2 to the third power is 8. Okay, so the meaning of this, that's what it looks like. Okay, so E, in other words, E to the, once you get 4.654, that means E, which is about 2.718, let's go ahead like this. That to the 4.6 power, 6.65 power, is equal to 105. Okay, so this is how you write it, because you're saying E to the 4.65396 power is 105. There you go. All right, terminology is kind of funky, but you'll get used to it. All right, that's how you write it with ln. Let's do another one, anti-logarithms. Anti-logarithm is the answer. Let's do another calculator exercise. And we'll find the base 10 anti-logarithm 4.316. Okay, even if this is completely crazy sign to you, keep at it. Okay, what you're asking is we're saying 10 to the 4.316 power is what? Now you should probably know that 10 to the fourth power, you go 10, 100, 1,000, and 10,000. Okay, now to the fifth power is 100,000. So something to the 4.316 power is between 10,000 and 100,000, closer to, I'm sure, 10,000 than it is 100,000. All right, so this is what you need to enter in. You'll enter 4.316, so do that in your calculator. Then you'll enter in 10 to the x power, all right? And most of you guys, let's go ahead and just do the 4.316. And then we'll pop in this here, 10 to the x power, boom, okay. In other words, the x is the 4.316. So this is calculating for us 10 to the 4.316 power, which is 20,701.41 whatever. Okay, that's a reasonable answer, right? It's more than 10. 10 to the fourth power is 10,000. 10 to the 4.316 power has got to be more than that, but not quite 100,000, and closer to 10,000 than it is 100,000. So boom, there we go. It just proves that our answer is reasonable. All right, we already talked about what the meaning is. If you write it as a log, this will tell you 10 to the 4.316 power is equal to 20,701.4 approximately. Okay, all right, let's use our calculator to get a value for E. Okay, remember that number is about 2.71828. Okay, here's how we're going to do that. All right, E to the first power is equal to E, right? Anything to the one power equals itself. Okay, so knowing that, let's go ahead and put 1 in, and then we'll put inverse, and then E to the x power. Okay, and then we should get it. Okay, so let's try it. So we have 1. Inverse also looks like this. That's the second, the inverse. We've done it before with trigonometry functions here. Okay, the second, and then we have e to the x power. Boom, there it is. Okay, so that is the value of e. Okay, let's take a look at using base 10 logarithms to simplify an answer like this. So there's a simple way to do it. Well, once you get the steps down, it's simple, but here's how you do it. You're going to, again, use a calculator. You just need to get used to using these steps in the calculator. If you need to go back a million times and check it, go right ahead and do it. Anyhow, we're going to change each one of these numbers. There's 3 numbers there. We're going to change each one of those and figure out what each number is to the, with a 10 to the power. And we're going to enter it in either this way in your calculator or another way in your calculator. Okay, so here's how we're going to do it. We will change, well, let's just go ahead and enter it in. We'll enter in 47,832. On the Windows 10 calculator, you're going to do it this way here. You're going to click 10 to the x power, then you're going to type in a number, then you're going to type in log. Okay, so let's go ahead and do that. So we have 10 to the x power, this one right here, there it is, and it sets it up for us. 47,832, then log. Okay, that number tells us that 47,832 is 10 to the power. So we have now 10, let's just go ahead and write this, 10 to the 4.68 power. That's what we got. Let's try it again. 59,463. So we'll start again. 10 to the x power. Type in the number. 59,000. Oops, that's 69. 59,463. Then we'll hit log, which means, well, we get 4.77. That means that number 59,000 and so on is 10 to the 4.77 power, approximately. All right, now we'll divide. 0.000817, let's put her in there. All right, so again, we'll clear that out. We got 10 to the x, and we have, what was it again, 0.000817, and then we have log. So we have 10 to the negative 3.08. Okay, so this is 10 to the negative 3.08 power. Okay, and we know how to do this now, right? Okay, we just 10 to the whatever, 10 to the whatever, this goes up here and becomes 10 to the positive, right? 3.08. Then we add all those together and get an approximate number, and 8 plus 7, okay, well, here's what we get. We'll divide that and then change it. This is our answer. We'll have 10 point, we'll call it 12.54. Close enough, all right? That's it. That's our power. 10 to the 12.54 power, 54 power, excuse me. And we're going to change this to an actual number by entering in 12.54, which is the power we divide by. So 12.54, and then back to 10 to the x power. Boom, there it is. So we're going to go 3, 6, 9, and then 12. So 3.47 times 10 to the 12th power is how we do that. Okay, ready for another one? All right, we're going to try using base E logs to simplify the same exact problem we just did. So we're going to change each number to an e to the power gives us this. Okay, in other words, e is about 2.71828. Okay, so 2.71828 to the what power? It gives us 47,832. Okay, so we can do that the same kind of way. We're just going to enter in the number 47,832. Then we'll put, here we go, and there we go. And 10.77, we'll call it 10.78. So that's going to be 10.78, that's the first one. Okay, second one, 59,463, so 59,463 to the, what power is it going to be? Oh, 10 to the 10 to the 9, or 10.99 power. And then we have 0.000817. 0.000817, and that'll be 10 to the negative 7.11. Okay, so e to the, what's that again? Okay, negative 7.11. Okay, boom, there we go. All right, now we know what to do. This goes up here and becomes e to the positive 7.11. Gone. Then we're going to add all these together. 10.78, 10.99 plus 7.11 equals 28.88. So then we go change this. In other words, this is e to the 28.88 power, and we're going to enter in that actual number and then inverse e. So we'll do inverse, which is second on sum, and then e, and boom. And you notice this is about the same number, 3, 6, 9, 12. And we get this time approximately 3.49 times 10 to the 12th power. Now before, we got 3.47 times 10 to the 12th power. And anytime you round up and down on logs here and there, it'll change the number a little bit slightly. But that's basically pretty much the same number. All right, let's take a look. We have anti-logarithm here with an E, and you can pause and copy if you need to. And don't forget our basic way of writing things down. We have a log, we have 2, 8, and 3, and we say the log of 8 to the base 2 is equal to 3. The log of 8 to the base 2 is equal to 3. So in other words, 2 times to the third power, is 8. So the answer to this one we're looking for is E to the negative 0.0325 power is our answer, and we're trying to find the answer. That's what we're trying to find. So E to the negative 0.0325 power gives you what? In your calculator, this is what you're going to type in. So 0.0325, and here's your opposite button right there. Okay, then we'll go to inverse, or the second button. And then there's your E, and then there we go. So 0.968 approximately. All right, let's try one more. Okay, let's try a couple more here, and we'll finish up here. Let's look at example 113.5. If y is 4,302, find log of y. Well, what we're actually asking is, and again, make sure you realize, when there is no number there, the number you assume there is 10. Okay, so the translation to this is 10. In other words, we're trying to find this, the answer to that. Okay, there's nothing there. 10 to the what power gives you 4,302, because we're saying that y is equal to 4,302. 10 to the what power gives you 4,302? Well, 10 to the first power is 10, 100, 1,000, and then 10,000, right? So the answer is going to be somewhere between 3 and 4, right? So here's what you push in your calculator: 4302, and then log. The answer is 3.63. So, in other words, the answer is 3.63. What this means is 10 to the 3.63 power gives you 4,302. 10 to the fourth power would be 10,000, too much. 10 to the third power would be 1,000, too little. So, I mean, other than using a calculator, there's no way that the average person can figure this out except for doing that. Okay, let's try another one. We have the natural log here of y, and let's find the natural log of y. So in other words, E, that's the natural log, which is about remember, E is equal to about 2.71828, and so on. E to the what power gives you 4,302. In other words, 2.71828 to the what power gives you 4,302. You're going to do the same exact thing we just did a second ago. So 4,302, and the natural log instead of just a log, boom, there it is. So 8.37, we'll call it, okay? So the answer is 8.37, which means E to the 8.37 power gives you 4,302. All right, let's go ahead and do a couple of practice problems. Go ahead and try A, and we'll pause it and come right back. Okay, let's take a look at A. So we have x equals natural log 0.0052. In other words, this means that natural log to the x power equals 0.0052. So you're going to put 0.0052 and then put natural log. And that'll be negative 5.26, we'll call it. Okay? So in other words, you have e to the negative 5.26 power gives you 0.0052. Okay, pause it and try B. All right, we're looking at the same thing here. We're going to go ahead and put in 51.4 and then natural log, boom, and there we go, 3.94 we'll call it. Okay, so the answer to this is 3.94, which means, again, that you have e to the 3.94 power gives you 51.4. Now, in other words, this is about 2.7, right, to the fourth power. So if you were to actually put in, just say 2.7 times 2.7, I'll just do the long way, times 2.7 times 2.7, and it's roughly where we are. A little different because we didn't do it exactly, we rounded off a little bit. Okay, all right, try C and see what you get. Okay, we have natural log and we have negative 4.16, so this means the natural log to the negative 4.16 power equals Okay, so we'll put in 4.16 and then the opposite. Then we'll do the inverse of the natural log, which gives us 0.0156, okay, 0.0156. If this is the answer, 0.0156, well, we can go ahead and move it over if you want to write it 1.56 times 10 to the negative 2, right? Okay, all right, try D. Okay, same thing here. We're going to go, log, and then we have negative 4.16, which is asking us 10 to the negative 4.16 power equals, so let's do it. 4.16 and the opposite, and the inverse of the log, boom, is going to be, oops, shouldn't have done that. There we go. Okay. All right, so this is 6.92, basically, times 10 to the negative 5th power. That even does it nicely for you. Okay, let's take a look at E. Express each number as a power, then use the rules of exponents to find the answer. First off, let's go ahead and find the 0.000612, and it's 0.000612. Of course, you can look at your, old stuff here. Oops, I need to put 10 to the x first. So 10 to the x power, 0.000612, then log, and which is negative 3. We just call it negative 3.2, which means this number can be written as 10 to the negative 3.2, okay? Now let's get 5.76. So we will go, let's delete that out. We'll go 10 to the x power, 576, and then log, yoink, and 2.76, okay? So that means that's 2.76. I just want to stop for a second and make sure you understand. What I'm doing is, in a roundabout way, is clicking numbers in certain instances, in certain order in the calculator, just so you will go, oh, 0.00606 in a certain way, typed into the calculator using logs, which is exponents, to find out that 10 to the negative 3 power, don't forget 10 to the negative 3 power is 1 over 10 to the 3 power, which is 1 over 1,000. This is about 1 over 1,000 right there. This is 576. Well, 10 to the second power is 100. 10 to the third power is 1,000. So it makes sense that this is somewhere between 10 to the second power and 10 to the third power. So that's 2.76. All right. Let's go to 0.0512. And we will go 10 to the x power, 0.0512, and then log, yoink. And that's going to be 10 to the negative 1.3, we'll call it. Okay. So that's 10 to the negative 1.3, oops, negative there. We already have this as 10 to the negative 14, we can just leave it. Okay, so these both come up, and that's going to become 10 to the positive 1.3, and then 10 to the positive 14, so these go away. Okay, so now all we need to do is just add negative 3.2 plus 2.76 plus 1.3 plus 14, and that's the power that the entire thing will be to. So let's do that. So 3.2, and that's going to be negative, plus 2.76 plus, is it 1.3? Yeah, 1.3 plus 14, boom. There we go, 14.86, okay? Now we're going to go the actual number itself and 10 to the x power, boom, that'll be good gravy. Okay, so 7.2 we'll call it, times 10 to the something power. So 3, 6, 9, 12, 13, 14, okay? So that'll be, let's just call it 7 times 10 to the 14th power. Okay, now in the book it has something like, 6.92 times 10 to the 14th. Nah, close enough. That's good enough. You can go from there. So anyway, okay, hope that wasn't too confusing. Go back and use those, the methods, and look at those examples, and we'll see you guys next time. Take care.